Okay, so calculating distance between points. So using the Pythagorean theorem, we're going to find the distance between negative 1, negative 1, 2, and 3, 5. So these are the points. You draw the line going down, the line going across to form a right triangle, and you're trying to find the distance C. So we're just going to plug in the formula. So we're trying to find the distance in A and B. So B, look at B first. The x-coordinates measure distance from left to right. So this is completely horizontal. The x-coordinate on negative 1, 2, negative 1 is the x-coordinate. And the x-coordinate on 3, 5 is 3. So negative 1 minus 3, absolute value, because distance is never negative. So this is 4 units, 1, 2, 3, 4, 1, 2, 3, 4. So this is 4 units across. And A, you're looking at the vertical distance, you could just count it because it already has the squares there. So 1, 2, 3. So A is 3 units and B is 4 units. So use the formula A squared plus B squared equals C squared, or C equals the square root of A squared plus B squared. So A squared is 3 squared, B squared is 4 squared, and we're looking for C. So 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and the square root of 25 is 5. So 5 squared is 25. You notice something about this triangle? It's a 3, 4, 5. These are all whole numbers. Sometimes you might not get a whole number for your hypotenuse. Sometimes you might not get a whole number as your hypotenuse, but there are some triangles where you get all whole numbers. 3, 4, 5 is one of them. Another one is 8, 15, 17. There's many different ones. There's the one that's 5, 12, 13. You don't need to memorize them, but so you don't always want to do this Pythagorean theorem whenever you're trying to find. First, before I go on, does this make sense? Calculating the distance between the points, why you make a triangle, and how to use the Pythagorean theorem. Yeah, for sure. Okay, so you don't always want to use the lengthy Pythagorean theorem. C equals the root of A squared plus B squared, and plug in the units. It gets all messy. So what we're going to do is derive a distance formula. So we can just plug in the points that we get automatically into the formula. So if we're trying to find D, the distance, which is C, the length of C, and we have points x1, y1. This is the first point. The second point, x2, y2, the subscripts. So this is the second point. We can say that the distance between this point and this point is x2 minus x1. X point x2 minus point x1, and the distance between point y2 and y1. So y2 minus y1 is the vertical distance. X2 minus x1 is the horizontal distance. So given this as A and this is B and this is C, we can just plug in this formula for what the variables are. So A squared, that's the same thing as x2 minus x1. This is A. So x2 minus x1 squared, A squared, this is the A squared term. And B squared, y2 minus y1 is B. This is the distance. This is how long B is. So B squared, y2 minus y1 squared. And we're looking for C. So that's what D is. We're trying to find the distance. And this is how you get the distance formula. So now you have a distance formula. You can just plug in x2, y2, x1, y1 into this formula, and you can find the distance a lot more easier than the messy Pythagorean theorem. This makes sense how we got to define the distance formula, how we got there. It's not just plugging in the numbers, but we need to understand how we got here. Thumbs up, thumbs down. Did it make sense for everybody? Click, feel, yeah. Yeah. Feel free to ask questions if you have any. So here's an independent example. What I'm gonna do is I'm gonna copy this so that you have the distance formula to plug in. So here, using the 2 points, calculate the distance between these 2 points in the following problem. So you can use this formula to give you guys a few minutes to do this. You got it? Okay. Done. Okay, let's go for the problem now. If you haven't finished yet, we're just go over it. So we're gonna pick someone who's done already. Yab, would you mind unmuting your mic and showing me the steps that you used to solve the problem?
Can you hear me?
Yeah, I can hear you.
Okay. So first I plugged in um the X's
X's.
and the Y's. Like I just plugged in everything in.
Okay, so what'd you use
So
for X2?
for X2 I used what did I use? Oh, I used -3
-3. Yeah.
and then minus -2. And then for the Y I got negative -1 -4.
Okay. So then
Oh, I forgot to square it.
you forgot to square it? Oh yeah.
Uh-huh.
Easy to make a mistake, simple like that. So all you have to do is substitute it into the equation. Just remember to not forget squaring. Okay, so you can still just go through the rest of the problem. So -3 minus -2 is what?
Huh?
-3 minus -2. What's this equal to?
-1.
Okay. Then -1 minus 4.
-5.
Okay. So then 1 squared is, I
1,
mean -1 squared is 17.
1,
Then -5 squared is,
25.
so then it's just the square root of 26. You can't simplify a square root of 26. Let's try to take out a 4. It's not divisible. It's not divisible by 4. You just left with square root of 26. You can't simplify it. That's the answer. Yeah, make sure to follow the equation. All you have to do is substitute. One thing that Hayab did differently is that she made this her second point, and she made this one her first point. So it doesn't matter which point you can make, which one you make your second or first. It just matters that you have to stay consistent. If this one's your second one, then both the x, this is x2 and this is this is y2. If this is your first one, this is x1, this is y1. If this is your second one, then this is x1. I mean, this is x2 and this is y2. If this is your first one, then this is x1 and this is y1. So just make sure to keep it consistent, whatever one you use second or first. Okay, very good. Yeah, just make sure it's square. Thank you. Did that one make sense for everybody? No, that was a little bit weird. Okay. Yeah, it's just substituting. I know you guys remember whenever we were evaluating equations, we just substituted values. That's the same thing we're doing here. So we're evaluating. Make sure to ask any questions if you have it. Next one. This is a cool thing you can do if, now that we know the distance formula. So if you're given 3 points, you can determine whether they form a right triangle. So the way that we're going to do this is that we're going to prove it using the Pythagorean theorem. So the Pythagorean theorem states that for there to be a right triangle, the the square root, I mean the square of the of side A, side B, the sum of them has to be equal to the the third side squared. So A squared plus B squared has to be equal to C squared for it to be a right triangle. You just can't look at the angles. Oh, that's a right angle. No, it could be 89 degrees. It could be 91 degrees. the way to find out that it's a right triangle is using the Pythagorean theorem. Pythagorean theorem. Okay. So knowing this, we're given 3 points. We have to find the distance between each of the 3 points to find the side lengths of A, B, and C. So you just use your distance formula. The distance between 1, -1, and 3, -3, you can say that that's side A. So they did the distance formula. They plugged in the numbers for x2, x1, y2, and y1. Then they got the root of the square root of 8. So side A is square root of 8. Side B, the distance between -1, -1, and 3, 1 is uh, they just plugged in the values for in the distance formula, x2, x1, y2, y1, and it comes out to be the square root of 8. So for the last point C, it's the distance between 3, -3, and 3, 1. So they just plugged in x2, x1, y2, y1, and they got 4. So now that they had all the side lengths, they found out all the side lengths using the distance formula between the points. You can check now to see if it's a right triangle. So a squared plus b squared equals c squared. Side A was the square root of 8, and side B was the square root of 8. Side C was 4. So whenever you square a square root, whenever you square a square root, the square root cancels out and the 2 cancels out. So it's just 8. You didn't have to do this step. Whenever you square a square root, it's like it's just like you're removing the square root symbol. You're removing the radical. So it just becomes 8. Both of these become 8. You can multiply in between inside the radical. 8 times 8 is 64. The root of 64 is 8. But it's easier just to get rid of the radical. So that's something you should note here. So 8 plus 8 is equal to the square root of the square of 4. So 4 squared is 16. 8 plus 8 is equal to 16. Yes, 16 is equal to 16. So yes, these form a right triangle. And in fact, since side A and side B were the same length, they were both the square root of 8. It's an isosceles right triangle. It's a special name for it. This one was a little bit long. Did this one make sense? I'm not gonna make you do independent practice on this because it would take too much time. Did this one make sense? It's a little bit long, but just if you had any questions throughout the process, just make sure to ask it in the chat. Thumbs up, thumbs down, yes, no, maybe so. Yeah, okay. Okay, midpoint formula. So this is just to find the middle of a line segment. So let's look at this. So you have a line segment, point A, point B. You're trying to find the middle. You're trying to find the midpoint. This is called the midpoint. So how do you find this? You can use this formula. It's pretty much just the average of the x coordinates and the y coordinates. So x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. This is how you find the midpoint ordered pair. Yeah, so you're just finding the average of the x values and the average of the y values. Let's see an example of this. So we're given the points -1, -2, and sub and 4. So sub and 4, -1, -2, you plot on the graph. Let's try to find the midpoint using the formula. So the first thing you can do to avoid any confusion is designating one as your first point and one as your second point. So this one, -1, -2 is your first point, 7, 4 is the second point. So x1, y1, x2, y2. Now it's easier to plug in the formula. So for x1, since it's -1, plug in -1. x2, 7, so -1 plus 7 is 6. You divide everything by 2, you get 3. So now the y1 is -2, y2 is 4, so -2 plus 4 divided by 2, -2 plus 4 is 2, 2 divided by 2 is 1. So the midpoint is 3, 1. You can actually see here that it looks, you tilt it, it looks to be it's in the middle. You plot it. We just proved it with math. Did this make sense? Calculating the midpoint of 2 points of a line segment. Thumbs up, thumbs down. You're gonna do an independent practice, so I want to make sure. No, maybe so. Yeah, once you guys are understand it, so find the midpoint between -6, 5, and 6, -11. Clear that. Good. I'm gonna wait in 1 minute. Okay. So anyway, it's 139. I'm gonna go with problem. Okay. So I'm gonna ask someone to unmute their mic. Aldo, would you mind unmuting your mic so you can explain to me how you solved the problem?
Can you hear me?
Yeah, I can hear you.
Okay. So first I plugged in the X1, the X2, the Y1, and the Y2.
So which one did you designate as x1, y1, and x2, y2?
Oh, I put -6 as X1 and 6 as X2,
Okay.
and then uh, 5 as 5 as Y1 and -11 as Y2.
Okay. So then you plug them into the formula, correct?
Yeah.
Okay. Okay. So what'd you get at the end?
I got 0/2 and -6/2.
Okay. What is the simplified to?
0 and -3.
Okay. Thank you. You're good. So the midpoint between -6, 5, and 6 of -11 is 0, -3. These ones are not too hard because all you have to do is plug in the formula, the midpoint formula. If anyone had questions with this, ask in the chat. If not, thumbs up. Yeah. So we're done with the PowerPoint. Now I'm going to do a little bit of review with everybody. So where's the origin located? Again, I just want to review that. At what ordered pair? What's the ordered pair?
0, 0.
Okay. Yes, that's right. Oh wait, let me pull up something. 0, 0. So what's the system? What's the graph name? What's the name of the graph? Like the system, the coordinate system. What is it called? There's two names for it. I mentioned
Inner
it.
plane.
The plane. Yeah, that's the area where everything is graphable. What's the system called? The the coordinate system. It starts with R, or it can start with C. It's the name of the graph. I mentioned it very briefly in the beginning. No, not collinear. So, so the name of the system is the rectangular coordinate system. So the system where there's two real number lines and they intersect at a right angle. This is called the rectangular coordinate system. Rectangular coordinate system. And I said that an alternate name for this is the Cartesian coordinate system. Uh, that's named after the person who made the coordinate system, Rene Descartes. So he made the Cartesian coordinate system or the rectangular coordinate system. That's the name. Okay. Pair. So what's the first number in an ordered pair? What coordinate is that? Just type the letter. The first number in an ordered pair is the blank coordinate. Yes, X. And the second one, the second number is the what coordinate? Y. Good. Okay. I'm gonna start asking other people because you're answering all the questions. Okay. Okay. So in what quadrant is both the x coordinate and the y coordinate positive? What quadrant are both of them positive? Mikya. Both the x coordinate and y coordinate are positive.
What did you call him?
I called Mikya.
What did you ask?
In what quadrant is both the x coordinate and the y coordinate positive?
1.
Yeah, quadrant 1. That's correct. In which quadrant is the x coordinate positive and the y coordinate is negative? Maraki. I repeat. Okay. Yeah, you're correct. Correct. Very good. Okay, let me go on. Another question. Okay, so if the points are all on the same line, what's another name for that? I think someone said it already before. Another question. Nathaniel.
Yes.
What's the name for points that are all on the same line?
Yeah. I don't know.
Okay. So remember whenever I was talking about co-workers, they all work for the same company. They're co-workers. So the points are collinear. They're all on the same line, collinear points. So these points, they're plotted on the same line, they're collinear. Actually, I think you came a little bit late. I don't know if it was when we started this, but
Why is your class?
the next question. Okay. Who's gonna be hard to ask? Ask another one. Okay. What theorem do we use to find the distance between 2 points? What theorem? Not the formula, but the theorem. Anyone can answer this one.
Can you repeat it?
What theorem do we use to find the distance between 2 points? Not the formula, but the theorem. A squared plus b squared equals c squared. Plus with p. N to the n. Yeah, good job. Okay, that's it for today. I think you guys got the concepts down. I was just quizzing you guys. I think you guys are all on guard. But before I end this meeting, if you wanna see any